We got up bright early in the morning of day 5 because we're heading to the John Prince Research Forest for the rest of the field camp. Their research station is located by the Tazaran Lake, about 45 kilometers north of Fort St. James. It's a stunning place, peaceful but vibrant, and I miss every minute I spent at the research forest. A family of open range tenure holders came over and taught us what it's all about running a lighted guided range cattle business and their relations with forestry and other values. I know nothing about cows, so I was pumped to learn, and the first thing they taught us was the terminology. It's not free range cattle or open range cattle, it's lightly guided range cattle. They don't just let the cows run around completely free. They have various measures to lightly guide the cows to be at a specific area at a particular time. Larry has this nuanced love and hate relationship with forestry. Thick pine plantation alter the hydrodynamic and soil pH, which yield plants that cows don't like. But he also owns a woodlot and curious whether some form of thinning could actually benefit his open cattle business.
Really noticeable. The last 2 years it's been really big. Is it under the forest cover, we're not getting any snow. So what's been happening is the snow has been settling on the treetops, and then you get kind of a warm day, a gentle breeze, and all of that snow, it's called sublimation. It turns to a gas before it turns to water. So that all of that snow sublimates and doesn't reach the ground. So the Nechaco Valley is a prime spot for this experiment because it's a great big bowl. This is all glacial till here, and this is what feeds all the aquifers down in the valley. So that's why they have them monitoring wells down in the valley, is they're concerned that something's going on with the aquifers. I know it's affecting our creeks because we've watched this one here go dry. And I think it's part of the timber thing. So I think you guys are going to get to talk to Liam, right? Yep. Liam is a really smart guy. I like a lot of his ideas, but I don't like his one idea. So his idea is, and I hope you guys call him on this. I'm going to feed you some BS, and you can run it by him. But his idea is, and he's driven by economics. The sawmills want timber, and he's driven by economics. But he wants to go in and thin this like they do in the Carolinas. Like they go down and they actually thin 3 times. They go in and they take out the pulp. They go in and take out a few saw logs, and then they come back and get the boards. It's a 3. So he wants to go in on a block just about like this. Probably getting fit. This was planted in '89.
The one we were at that woodlot thing, it was 30 years old.
30 years old.
Yeah.
So she'll maybe tell you about it, but anyway, she's running it. Because we have a woodlot too, and you're going to hear me. I think I'm a successful hypocrite because we got 1 million trees. So I curse trees. But they're what actually paid for the succession plan. The cows won't pay for nothing so far. Anyway, so what Liam wants to do is he wants to go in and log strips and open up the canopy, provide more. He thinks his ideas is going to, or part of his sales pitch is going to provide some wildlife habitat. Supply the mills with some timber. I think we would be better off to go in and log, say, 1 hectare. Break it up into bigger, so I had a good friend that he's been working in Africa because the desert is coming in. I don't know, I can't remember what part of but the desert is creeping in. So what they're trying to do is create what they're calling permacultures. And if you go to your Greek, perma means edge. And if you go in here and log a little strip that's 4 meters wide, That does not create an edge. That is not a permaculture in my friend's philosophy. If you go in there and you create a circle, you actually create, in a circle, there's more edge than there is in a square, right? Liam's doing the right thing because he's trying to move these policy analysts somewhere. And if you don't take any action, by not taking action, that is an action, right? Because things are gonna, anyway, so I think, and you guys gotta run this by him, but if he just went in there and take half a hectare, you're gonna create sunlight, you're gonna create a spot where you can have a whole bunch of different plants. Whereas if you just do a strip, you're probably gonna get a very few, a limited number of plants that are gonna like to live in that strip.
I think Liam's strip is he cut the trail in, but he'll reach in and cut both sides, right? So it's like clear cut
Yeah.
basically on the trails and then thinning on both sides.
And he needs the strips in order to get the logs back out to where it's sold. So the reason he does the strips.
So you still think with the clear cut on the trail and then thinning on the side, probably based on the prescription, but it normally takes about a third of the trees out at one time. So if you look at this, every 3 trees you take one out on both sides, but you clear cut on the trail, that's still not enough in your opinion for the plants to grow? Or for the biodiversity?
Yeah,
Gotcha.
no, I still don't think there's enough sun that gets in there.
They like disturbance. So when they, back in the day, so this was logged in '89, they loved these blocks for about 3 years. They just love, they love it. They just camped here for about 3 years. And then the trees start getting this big, and then something kind of happens. And we don't know what it is, but they'll find, if they can, they'll find somewhere else to eat. If they can, if there is somewhere else to eat. But again, I will be straight up honest, that circle is going to be more long-term grass for our cows. They'll get a spot like that, and if they, once they kind of know it, they'll kind of go back and camp in it and keep using it. So
for you guys, you'd want us to have larger cuts. You want for us to have kind of bigger cuts, not huge cuts, but like bigger cuts to allow for the cattle to go grazing.
I think that's the old days, though. That was back in '89. These big cuts were great. They get up on the hill here, the mosquitoes, you know, the wind blows the mosquitoes away. It's a new ball game with this. I don't know what we want. I don't quite know what we want.
With these drier summers.
Drier summers, new plantation. You know, we've already changed the structure of the soil by doing this. So I don't know what we want. Part of the rotation stuff right now, you see the rose hips are starting to get. So our cows will probably start eating them in the next week or so. It causes us grief because all of those seeds are in that gut, and they'll come home to our private pastures, and they'll shit them out, and we fight rose bushes like they just take over fields. So that's a good thing about I mean, that's a kind of a bad, it doesn't hurt, I mean, it hurts us because they do pack all these seeds, but these ruminants are probably the best seeders in the world. Like one of the things you guys will definitely hear in your career is as a cattleman, we had nothing but grief because they wanted to take all the cattle off these big burns, and they kicked the guys off the burns. Stupidest thing you could ever do. Because inside a burn, if you guys ever, like we flew over this big burn here, we flew over a big burn on the way to Mackenzie the other day, but inside of that burn there's patches of don't, and they're alive with your new crop of seeds. But you got to move those seeds from there and scatter them around. So what these ruminants will do is they'll go in there and eat that, and they'll pack them over there in a burn spot, they'll shit them out, and stuff will grow. But you got the policy analysts in Victoria who see these cows making these trails and all the... Anyway, it's the dumbest thing you could ever do. You want to get them cattle out there, and you want to get them, if you really want to seed the thing, feed them a whole bunch of whatever grass you want to grow. Feed them the grass the day before and then kick them out on them burns, and it's all going to be seeded.
Now, like, there hasn't been logging in this area for years, right? It's all just grown up pine trees, and so we're having to utilize patches like this. The burn patch we called, so this is from the Norman Lake burn. Do you remember what year that was?
2015.
2015. The spring, right? We talked about it already. The spring burnt all that. Before it was just like dead pine trees. So they burnt it, and then a few years later, PacBio came in and bulldozed it all into piles. They chipped it and hauled it away for pellets. So they just left these huge, huge areas of like nothing. So Dad worked with PacBio and our district manager, and he was able to get 39 hectares set aside where they did not plant trees. And it was kind of the areas where it's going to grow, like kind of lower areas and edges. So they're not going to plant trees there for moose and for cattle and for some diversity.
I was surprised, and please forgive my ignorance, how much cows love disturbance. They told us sometimes cow would be roaming around in the burn area and come home black with twin. And having twins is a sign they're doing great. I'm also glad to hear that forestry treatments can potentially help their business. I think the key is to create openings and promote a grassland ecosystem, which means no planting.
What I'm going to talk about is trapping a little bit, but more to the point, I'm going to talk about how trappers see the forest, which you guys learn about, right? But what you learn about the forest is quite different from what I see in the forest, and that's the part that I really want to show you today. But we'll start out first of all with the stuff that we trap. So if you come a little bit closer here.
After a quick lunch, Gerd, a local trapper and Roy's high school biology teacher, came over and showed us what trapping is all about and his perspective on BC forest management. He showed up some of the critters he traps and the tools he uses, and it's super, super cool.
Beavers, everybody knows about beaver trapping back in the day, right? And hats, you know about that? What kind of hats were they? What were they made out of?
Beaver felt.
Yeah, beaver felt. That's the point. It was not beaver skins, it was beaver felt. So people would get a beaver skin, then they would have somebody go along and hand pick all this long coarse hair out of here and, I don't know, do what with it, throw it away, right? The way to do that is you leave this thing sitting in water until it starts to rot, till the leather starts to rot, and then the hair picks out quite easily. And then they would take all this fine stuff, you can see some of it here on the edge, it's easier. They would take this little fine stuff and make felt out of it. And the reason that was such a big deal, because the fine stuff on the beaver is all zigzaggy. It grows in little tufts of maybe 50 little hairs at a time, but they're all zigzaggy. And if you know anything about how felt is made, you mix it with water, you swoosh it around, you put it on a screen, and the water drains out, and you got all this tangle of hairs on there, and that makes felt. But if the hairs are all zigzaggy, they interlock like crazy, and they don't come apart. So when you have a hat made out of felt, it doesn't sag, and it doesn't, you know, when it gets wet, fall apart and pull apart and turn to slop, right? And they use that nowadays for making cowboy hats, expensive cowboy hats. If you buy a cowboy hat for $100, I don't know what they use, dirt that they swept off the floor of the shop. If you buy a cowboy hat for $600, then it'll have a tag inside that tells you what percentage of the felt was made from beaver hair. I'll say 10%, 20%, 50%, 60%. If you buy a $2,000 cowboy hat, it'll say 100% beaver, and that's what those are made of. And that's why the expensive ones last really well. They don't lose their shape, they keep looking nice. I was talking about looking up fur coats, and I thought, I wonder, like how much do these fur coats cost? You know, we produce all this stuff. What does it cost when the final person actually buys it? So I looked around, and I thought, what's the most expensive fur coat out there? And what I found was $160,000 for a coat.
Made of?
Made of marten. They call it sable is another name for it when it's a fur, but it's the animal is called a marten. That's this stuff here. And it comes in different colors. $160,000. So, you know, unlike the give up your avocado toast stuff, if you give up your fur coat habit, you could probably afford a house. Who would buy a coat like that?
That much.
The guys that don't pay taxes.
Gerd showed us many different kinds of traps he's used throughout the years. It's quite common to stumble across their trap boxes in remote areas. I remember once we were laying out this block deep in the middle of nowhere. My coworker and I discovered a unmapped cut trail wide enough for a quad. So as we're collecting the spatial data of this trail, a trapper suddenly appeared, furious, cursing at us to leave. It was a tense encounter. The story is much longer, but we complied. This experience early in my forestry career was my first real lesson in how strongly some people feel about what we do in forestry.
You will occasionally, when you're walking through the bush as a forester, or in any other capacity, see boxes sort of like this. And they can be either on a tree like this, or they can be on a tree like this, or they'll be on a horizontal pole like this. But they're all basically the same thing. So you have this box. And then the trap goes in here like this. And once I have that safely in there, I take my safety tool off, which is always a bit of a hassle. Ah, come on. And then I take off the safety hooks off the springs so that the springs can spring. And then I put some bait in the back here, or some scent, or something. So one of these guys comes along. He goes, oh, look at that. Looks like, smells good. Looks like good. Something to eat. All right, what am I going to do? How am I going to get there? He goes over here and he goes, oh, there we go. I can just go in here. And that's the last thing that he thinks. They're like instantly dead like that. And that, you notice, is pretty much on their head, back of the head. Right? And they're just, a lot of times when I pick up my traps, if they're on the ground, they'll be sitting there exactly like that. They didn't even pull the trap out of the box. It's just over, right? So that's how these traps work. So this burned about 8 years ago, I think, roughly. And parts of it have been salvaged for pellets, and parts have been left alone. And this is one of the parts that's been left alone. There's some other parts that are actually nicer to look at, but they're way down the road, so we don't have time to go there. The first thing I want to draw your attention to is, see these trees that are growing in the shade and horrible shaded out by all this aspen and stuff? Notice that the growth they're putting on, I've seen better growth on trees, but I haven't seen better growth during 2 drought summers like this year and last year, right? And actually the year before as well. So this tree is actually doing really quite nicely in spite of all the competition. How on earth can that be? Because that's not kind of what the standard thing, is it? Look at all this competition that's holding back our crop trees. I talk to foresters sometimes, and they say, well, you know, if we harvested straight conifer, we have to replace it with straight conifer. And I say it wasn't straight conifer when you harvested it. And then they go, well, where do you think this aspen came from? It didn't sucker up from pine roots. It suckered up from aspen roots. There must have been aspen in this block when you harvested it. Oh, never thought of that. And that's actually what they say. That's actually what they say. I never thought of that. Where do you think this aspen is coming from, all this competition? So the point is, it was a mixed forest to begin with. Although, at that mature stage, when they were planning to log it before it burned, at that mature stage, it was dominated by the conifer, but it was never pure conifer. And at an earlier stage, it looked just like this. See, it burns. Nothing was done here. No planting, no spraying, no nothing. And this is what it looks like after burn. is this is what comes up. And then the pine come up, and eventually the pine dominates over the aspen, and the aspen die back, but don't die out completely. And then there's that question about water. So when the leaves come off these aspen trees, the snow all comes right down to ground level and melts into water in the spring and soaks in. So there's a good water supply. Whereas if it's when it's all plantation with pine, a large percentage, in some cases I've read 70% of the snow never reaches the ground, right? So you're aggravating the drought by not having the aspen in there. And of course, when the pine are little, their roots are only this far down. Later on, they're that far, and later on, they go way down deep, 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 right? But when they're little, they actually are more moisture dependent than they are later in life. And it's the aspen that arranges for the moisture as well as a shade to keep things cool and not evaporating so much. There's absolutely no reason why we need to go around planting trees in order that we would have another generation of trees in the future. They do that on their own. And that's what we're harvesting, is trees that grew on their own. We have absolutely no idea what's going to become of all these plantations that have been so carefully planted at this spacing or that spacing or the other spacing, and then protected with brush saws or with herbicide. We have no idea what's going to become of them, and all of us, including you guys, will be dead before it's time to harvest those. So you'll never find out either what that accomplished. Your grandchildren will be at the age to be foresters, to become just new foresters when those plantations supposedly should be mature, right? So we don't actually know what we're doing, what's going to happen, how that's going to work. But we do it anyway. And the reason we do it is because when we do it, we can pretend that we're growing the trees much faster than nature can do, and therefore we can harvest a bigger AAC right now, right? I don't think the companies that push this stuff, I don't think they care what's going to happen 2 generations from now. The people who work in those companies, make the decisions, they won't be around. Do they care if it takes 80 years or 90 years for a tree to grow? Not my problem, I won't be here, right? But your grandchildren will care. It'll make a huge difference to them. Not to mention all the other stuff that the plantations are preventing. Like the plantations won't be good grazing for cattle. So the cattlemen can't get anything off that crown land. They're no good for trapping. They're no good for hunting. There was once upon a time the wisdom was the best places to hunt for moose was in old cut blocks. But that was before they changed the rules to what we have now. And the cut blocks now are completely useless for moose. They walk through them sometimes, and it makes them visible, so if you're hunting, if a moose walks through there, you can see it. But they can't live in them. There's now some research that's saying, south of Andrew here, where we've got such extensive horizon to horizon pine beetle salvage replaced with plantations. There's some research now that's saying that the moose not only can't live in those plantations, they actually die in them. Because what happens is that the moose have some little place where there's still a bit of moose habitat available, and then they live there and they have their calves there, and when the calves leave, which they have to do, they get kicked out. The bull calves get kicked out and have to leave. The cow calves, female calves, they get to stay in their mother's territory for as long as they like. But when the calves leave, they wind up in some of these plantations and starve to death there because they have no idea which direction to go to maybe find some food somewhere. And that they can go far enough through these plantations that they starve in the plantation as they're wandering through them, trying to find where can I go. So that's a bit of a grim kind of a concept, I think. Maybe you guys are okay with that, I don't know. But it's a bit of a thing. We were told, I'm so old, that I was around when they stopped doing selective cutting and started doing clear cuts. And the argument was we're just mimicking nature. A big area burns, that's just like a big area clear cut, right? The mature timber is gone and new stuff can grow. It was said, yeah, so we're just mimicking burns. And then when you compare what we mimicked over there compared to this, does that look like much of a mimicking? It's a little different to me. There's just so many things that aren't being mimicked, other than we're killing all the mature trees. That part is the same as a burn. But everything else is not even close.
Well,
And the other thing is that a lot of the mature trees that burned are still standing or they're on the ground and they're still part of the system.
That's right. The first thing that those standing trees do is attract beetles. Even before the smoke is cleared, the beetles are already in there. Beetles that depend specifically on hot, burned wood. They're laying their eggs before the wood is cooled off. And before those eggs have hatched, the woodpeckers are coming in and saying, look at the food supply we got here. And you know, that just starts the beginning of a whole entire new ecosystem that's different from what the mature timber was.
And thank you very much. Just a little thing to say thanks, and we appreciate it. Appreciate your help.
Oh, it's fun to come and tell them my nonsense. I hope you guys learned something, or I hope you got some questions to think about, or I hope you got some questions that think I'm maybe full of beans, and so you can go look it up and see what the truth really is. So,
The thing that is not a question is you got them thinking one way or another.
that's what,
Whether you're full of beans or other way around.
you know, when I
So I'm a soil scientist, and this area in and around the John Prince Research Forest is one of my favorite places in the whole world to do soil science. And I hope this afternoon I'll give you a sense of why I think it's such a terrific spot. There's just a huge amount of really cool variety here in, first of all, the underlying bedrock geology, and that has an influence on soils, some of which we can see and feel, and some of which is sort of unseen. It's in the chemistry, it's in properties that are not visible to the eye, but which have a big influence on the way ecosystems function. So what I want to do this afternoon is just sort of give you a little bit of a taste of why this is such a cool area, a bit of a refresher. So after I finish talking to you for about 20 minutes or so, those totes over there by Diogo have got a bunch of soil samples, and we're going to get our hands dirty so nobody leaves here with clean hands. It'll be refreshing your memory, your tactile memory, for identifying soil structure. Okay, well, we're standing right next to kind of a special plant. So right about 40 centimeters to the left of Erica's left foot, you can see that fern. So anybody know what that plant is called?
Maiden's hair.
Maidenhair fern, yes. Maidenhair fern is a lovely plant. These are kind of scrawny little specimens. I mean, I've seen it growing elsewhere on moister sites where it's knee-high and much happier looking. But what's distinctive about it is that in the interior of BC, its occurrence seems to be pretty much restricted to soils that have been derived from ultramafic bedrock. There's not really any glacial deposits here. They've all sort of washed off. What you're looking at is soil formed directly from the weathering of this bedrock type. So it inherits all of the weird chemistry of that bedrock type. So when we did a chemical analysis of this material, we got all kinds of strange properties. Extremely high concentrations of iron, 5,000 parts per million of nickel. Like an average bedrock, well under 100 parts per million of nickel. So, in fact, if you had enough tonnages of this, you could mine it as a source of nickel. So, very weird chemistry. And I also learned last year that this kind of material has a very distinctive cultural application, which is that it can be used to provide very distinctive garments that have a color that is permanently fixed. So this was my most memorable retirement gift that I received. So a year later, I just want to thank Roy for having the wit to think of this and organize the class from last year to provide this very lovely gift, which I also got autographed by all of you. Now, I haven't had the nerve to wash this, but
Be careful. Don't wash it with anything else. It did soak for 4 days in my garage, but you never know.
yes.
And I actually heard Paul one time here, I think it was 2022. I don't think I've ever heard a professor say this, This kind of site with these kind of characteristics really turned me on.
I don't recall saying that. You want to see what the asphalt boys on the asphalt crew used to do?
Yeah.
But you know, you're working away, throw your shovel
jump
down.
on it?
Yeah, sorry, you just, instead of reaching down and
Whoa!
see, asphalt worker. This is a very good example of what we call an orthic gray rufosol on glacial lacustrine sediments. So all of those areas that I showed you in those maps showing the flooded areas, and I mentioned the farming areas around Vanderhoof, this is the underlying soil. So where we are right now, this is probably in the agricultural land reserve, quite likely, just because this is the kind of soil that is the basis for agriculture in much of central BC. And from a silvicultural point of view, it's amazing. You just cut it down and walk away and come back in 50 or 60 years and do it again. You don't have to plant, you don't have to do any of that silvicultural stuff. It just grows back by suckering from the root systems. The catch is that those root systems for aspen are very close to the surface. They're in the forest floor and the top part of the mineral soil. And in northeastern BC, the soil textures are generally pretty fine. So if you are sloppy about logging, or you're doing it when it's like too wet or in the wrong season, it's so easy to wreck those aspen root systems, and then you don't get regeneration, and it just becomes an absolute hell of grass and willow, and you just don't want to go there. So so yes, I think that was what you were reminding me of. Yeah. Now, we don't have aspen as a commercial species in central BC, but you know, there's other reasons to be careful. We find, for example, spruce tends to be a little fussier about soil conditions than pine. So if spruce is your target species, again, another reason to look at the soil limitations, and for something this fine, winter only.
So to summarize, if it's clayey and there's aspen in there, because there's a high compaction that will kill the aspen and turn it into a grassland willow type post-harvest structure.
Yeah, and I mean, I've seen attempts to reestablish spruce plantations on sites like that that have been screwed up, and it's just an absolute nightmare, because there's this grass called calamagrostis, which is like this, and imagine trying to put a little seedling when you just spend a fortune on vegetation management, and it's just a complete nightmare, and it's 100% avoidable. You know, just don't go there in the wrong season. So these soils can be very productive for certain species. You have to just treat them carefully and be mindful of their limitations, and you know, you got a great plantation. Just be smart about the dirt.
And also in forestry, we typically only care about the first 30 centimeter of the substrate, mineral substrate. And I'm always wondering the reason behind those, and then if you agree with that kind of approach.
Well, I mean, to a certain point. So if we just look along this exposure here, and you guys probably noticed this where you were digging, is that yes, we do have some deep root penetration here, but a lot of the fine roots are pretty close to the surface. So that would be kind of the rationale for being particularly concerned about that top, because that's where a lot of the biological activity is. Like, I mean, right here, there's not a lot of organic matter, but we've got a more granular structure here with lots of more fine roots. So the fine roots are there for a reason. So that more granular structure would probably be better aerated. I mean, what's limiting things here is the growing season length. And if you've got a clay-rich soil, that means it'll have a high water holding capacity. A wet soil is a cold soil, right? It's just got more thermal mass. It's going to take more growing degree days to warm it up to the point where the roots can start doing something. So effectively, you've got a shorter growing season here than you would on a soil at that last site, which wasn't as fine textured as this. And so that's your main limitation, is growing season length. So you don't want to do anything that causes this somewhat better structure, better aerated zone near the surface to deteriorate. It's very precious. So that's another reason not to put equipment on this when it's soft and moist. And in the springtime, I mean, I've done this at Eliza Lake. Right after snowmelt, this A horizon, you can just completely obliterate that structure with one press of your hand. It doesn't take much force. So it's that's where all the action is. I don't know if that answers your question.
That did.
Regardless of the soil texture, Paul, I mean, from a soil scientist perspective, wouldn't it just be better to only, I know economically it's not feasible, but to only ever do winter logging on a thick layer of snow?
Well, where you've got coarser, I mean, sort of in three, you could kind of divide soils into three broad categories based on texture. So something like a sand, something like we're going to see at the next site, which is basically just sand and gravel. You can do whatever you want any time of year. It's basically bomb-proof. But those aren't necessarily particularly productive sites because they're droughty, right? Mm-hmm. At the other extreme, you've got something like this, where there's a clear reason to be very careful about moisture content and season. Because the soil is very fragile. And then the most abundant condition is what's in the middle, and that's the soils formed from till, which occupy the greatest part of the landscape. And depending on where you are, they can lean towards the sandier side, or they can lean towards the finer textured side, or somewhere in between. And that, varies across the province. And so those would have probably medium level of compaction hazard, where it's a bit of a judgment call as to whether, in theory, you could do it in the summer, you could log in the summer and do site prep in the summer, but you've got to pay attention to the moisture conditions. So you have to wait until later on in the season, and sometimes people don't want to wait. I mean, think about this year. We had pretty damp conditions in June, and it would be very unwise to go on to that kind of sort of what they call moderate compaction hazard material in the spring. Right now, probably okay. And then, so there's a seasonality aspect of it, and then there's also site variability. So you all know from being out in the bush that things are not uniform. You go 10 or 20 meters down a hill, you may have a little wet area, which is a whole different world in terms of moisture regime. So that becomes sort of the limiting area for that potential block, because that's where you can get into trouble. I mean, I shouldn't. I mean, I'll be telling you war stories all night, but I mean, this is not hard science. This is just common sense, and using your fingers, which are trained now, to be aware of your soil conditions, because it puts constraints on what you can do. But it's not hard to learn this stuff and understand what it means, and someday you might prevent a big mess.
Ecotyping is one of the most important tasks for layout people. It's a pretty complicated process, but long story short, the end goal of ecotyping is to map out the size series of the block. And because size series is a key factor to determining standard units in block site plan, people also call ecotyping site plan mapping. If you're a planter and ever wondering where those planting species and densities are coming from, well, it all came from the ecotyping at the layout phase. Just like Paul mentioned before, mastering soil texturing and understanding the associated environmental and operational hazard of certain soil will save your company so much money in logging, silviculture, and sometimes save lives. And I learned that lesson the hard way. It was an incident that happened to a logger logging one of the steep blocks I laid out a couple years ago. No one was injured, fortunately, but 2 machines were damaged. You can always point fingers at loggers to be more careful, but I think it would have been 1000% avoidable if the layout people, aka myself, properly figure out the soil type and type out that area on the site plan. It's a really long story, so I would probably share that on the podcast or something later.
You can use your new UNBC mug to have a nice drink.
Oh, thank you very much.
So,
Yeah, I appreciate it.
UNBC green.
Okay.
There you go, Paul. You've got
If you corner me and force me to pick my favorite day from this field camp, it will be day 7. It's a day focusing on silviculture, a newer type of silviculture, at least to northern BC. Lots of information, lots of discussion, and it keeps your brain going. Similar to Eliza Lake Research Forest, John Prince Research Forest also operates under a special use permit and heavily relies on log cells to keep the research forest functioning. Dexter is the big boss of John Prince, and Liam from Freya Logging logged for them for this exciting and fascinating adaptive silviculture for the climate change trial using processor and forwarder.
Page of the material that was handed out this morning, and it's a discussion about the JPRF ask or adaptive silviculture for climate change treatment. That is the area that we're about to walk in. And just as a bit of background knowledge there, the ASK network is actually an international network of, at this stage, 14 sites throughout Canada and the US that have been specifically set up to evaluate how different adaptive silviculture options can be used to make systems more resistant, resilient to future climate change. Okay. The JPRF one that we have got set up here, we started doing the planning for it in 2019, 2020. A key part of the whole adaptive silviculture for climate change exercise is making sure that the plans for what actually is going to be done on the ground is not just the decision made by a couple academics, it is actually a collective decision, collective options that are being defined by the big workshop structure. So in 2020 we had 3 days of workshop. The first day of the workshop was bringing in about 40 regional expertise, regional stakeholders, to have them think about what climate change impacts are going to be and how we can modify our silviculture systems in order to decrease the negative effects of climate change on our forests. After that, the workshop broke down into a kind of smaller subset where there's 20 people that were kept on board for the next 2 days, where we actually went through and hashed out what the actual silviculture treatments are that we wanted to put onto the landscape here. Okay? So, we've got these throughout North America. They're all aimed to address basically the same question, how silviculture can make the forest more resilient to future change. So it's a really nice comparative way of looking at very, very different ecosites. The type of forest we have around here, I can guarantee you, is much different than the pine plantations that are down in Florida. But we're using the same framework, we're using the same experimental setup that allow these cross-site comparisons across the whole network. Okay? All right, the treatments that are always going to be used, the first one is a control. So it do nothing. Go into the forest, measure it, don't do any type of silviculture, harvest operations whatsoever. Keep that as control that you're going to monitor through time. All right? After that, the first one, or kind of the lightest touch, is going to be the resistance. So this is how can we actually modify our forest systems so that they're more resistant to those type of perturbations that we're talking about. And it's not any one perturbation that we're thinking of specifically, it's what's going to be specific to that area. Is it going to be the drought, the fire, the insects, the invasive species? You want to build all that into the decision-making process. Okay? But the aim here is try to get a forest that is going to allow the attributes that we're trying to maintain, be it timber supply, be it wildlife habitat, show the smallest changes in response to those perturbations over a set period of time. That's the easy, that's the light touch. You then can go into the medium touch, that's the resistance. There, we're willing to allow the system to change a little bit, but we always want to come back to providing the same ecosystem services or the same traits over time. So we're not trying to make it so that there's no fire, but that after a fire happens, the system is going to come back to allow the same type of ecosystem services to be produced later on. Okay? The third one is transition. And again, all this project is being done through the lens of climate change. As we heard this morning, the climate is changing, we're getting warmer. We don't have a great idea whether it's going to be warmer, wetter, warmer, drier. That's something we're still trying to figure out. But we know that it's going to be shifting completely. So because of that, one of our treatments can be how can we actually pre-adapt the system so that it transitions into a state that is going to be better aligned with those future climatic conditions quicker. And that's the transition treatment. Okay? We said we're special here, that we did 5 instead of 4. The 5th one was we had to do a clear cut because that's historically what we've done. So we want to have that as another baseline treatment to figure out how the systems respond. Okay? I think at the last stop, Roy, maybe you mentioned it, that what is left behind is important. That's frankly the definition of silviculture. We think about what we leave behind in order to drive the forest into its next state. Okay?
It's really easy to think about border harvester as a 5-meter trail and about 15 meters in between. So the 5-meter trail width and then 15 meters where the machine doesn't travel. And we're putting our branches in front of us so everybody can see kind of this branch mat that I'm standing on. So we're not really impacting the moss down here very much. It's still intact, right? We still have a very intact duff layer here, so we didn't scalp this duff layer. And so when you're writing a prescription, if you want to do this, it's real easy. 5-meter trail, 15 meters in between. It's not always going to be exact because you're not going to like go side hill if you have to move over and go on the top of a little ridge or something. But you can generally let the operator come up with that matrix. He might move the trail a little bit in a few spots, but you don't want to come in and cut a skid trail on a side hill just because you want to keep your trail at 5 meters if you can just move your trail around a little bit, right? So, but the big thing, 5-meter trail, 15 meters in between. So it's basically a clear cut for 5 meters and then a selection zone in the middle. So the operator is going to cut everything in front of him so that we can operate, and then he's going to reach in and select. That's where the actual thinning happens. So you have like 25% of your volume removal here is just trails. It's just a clear cut, but the other portion is where the guy has to do his thinking. And he has to do his thinking anyways, because if there's a big Douglas fir in the way, we don't want to say you have to keep your trails at 5 meters and make him cut that big Douglas fir. You can just go around it, right? So the goal is to keep the basal area in the polygon within target, so you can have 17 here and 13 there, right? Like it's not a uniform system. So, well, can I say one more thing about the crews here? So we looked at VRI, it showed 15,000 meters in the general area, and then we did the LiDAR, and we thought it was 25,000, and Sue said there's no way it's 25,000, so we cruised it at 45,000, and we removed 40,000. So this is a 70% removal. So people are like, you can't do that, it costs too much. It's like $5 a meter extra. And how much was our planting cost in here? And we were talking about when to go into that pine stand next. So that pine stand's 32. Yep. This is 60. So this is, we'll just keep the forest at this level all the time. When it goes up in basal area, bring it down. Maybe at some point we have to clear cut it, but these spruce trees have a pretty long life in front of them, right? So just keep giving them lots of nutrients and keep them frisky and healthy. So yeah.
The question you asked when was up reminded me of some kind of Sand County Almanac stuff. You guys know who wrote Sand County Almanac? Aldo Leopold, kind of one of America's first foresters. And what you're saying, what Liam's speaking to, and what we see is, and this quote's just been pounding in my head since we stood here, and he said, a thing is right when it tends to preserve the integrity, stability, and beauty of the biotic community, and it's wrong when it tends otherwise. It says when it tends to preserve, it doesn't say completely preserve, but when it tends to preserve the integrity, stability, and beauty of the biotic community, that's the right thing. It's wrong when it tends otherwise. This is really capturing some of that, I think. I think he would be, if he was around, he might like this kind of thing relative to maybe some of the other things we've seen.
In the summer of 2023, I actually went to JPRF with a planning forester from a licensee just to learn what they're doing. The general manager at the time, Sue, who's now retired, gave us a detailed tour like we got this summer as a class. She talked about different areas in interior forestry and how her objectives as a forester shifted throughout the year. It's fascinating stuff.
Logged. It was logged in 1950. And during that period, the focus of the forest industry in BC was just to get a forest economy going. And so they were giving out licenses. They had very high utilization standards, so they were taking out the big trees. We can call this high grading, but it was, the forestry of the time. So I think what we can see here is, these are probably Douglas fir if we wanted to dig in. It was a sort of more wide-spaced Douglas fir stand. And what was in the understory was spruce and some of this balsam cigarettes, you know. And so some of the stuff that's come up was sort of in the original stand, and then some of it has come up since it. But it's in character quite a different forest than it would have been previously. And part of that also has to do with the exclusion of fire, you know, because a typical Douglas fir forest in this type would have had fire in it. The Douglas fir would have prevailed, but the balsam would be toasted, so it would be less. So this isn't what the natural forest actually looks like, but this is what we did our trials in, because there's a lot of this. I don't know, around Prince George, there's sure a lot of this sort of stuff.
Right.
So this was a bit different. So when I have the students out here, I like to sort of demonstrate at different eras in forestry in BC. They had different objectives, and the actions that were taken by the foresters had different consequences. And when I started doing this course, or back in the day, I guess, when I actually thought the forest I stopped out over there, which was more of an industrial 80s forest, which is the clear cut, the, you know, vegetation control, the planting, all that stuff, was what forestry should be. Now I'm thinking the forest we get here has way greater values for biodiversity. It's heterogeneous, it's got coarse woody debris on the ground, it's got gaps in places, it's probably got snags somewhere, although not where we're standing. And if for instance Dexter were here, he would contrast that and he would say, well, you know, that kind of stand over there is good. You know, rabbits like it, grouse like it, lynx like it. And for a period of time, it has some values for those critters. Then it kind of peters out. And then, of course, it's used by other critters, but it doesn't have some of these structural components or legacy components that increase its biodiversity over its rotations over the whole time, right? So he is more inclined to say any amount of retention you can keep in it is useful. And so he would come over here and he'd say, well, birds like this, you know, and the various critters like this, because it has more of those attributes we're looking for. So in forestry, now that's our challenge, is can we create blocks that kind of retain some attributes that will kind of be there throughout the rotation and help the critters, you know, because it sure looks like we're shifting into a truly multivariable forestry now.
As someone who's worked in the industry for a while and now back to school to learn how we can do a better job as foresters, the journey has been filled with frustrations and confusion. It's frustrating because almost everyone is pointing finger at us for creating negative environmental impact on BC forest. I agree with some allegations and disagree with some. I'm confused because I'm not sure how we can do a better job as a forestry community when mills keep shutting down and people keep losing jobs. We're talking about real people working in the forestry industry, grinding hard to provide a better living environment for their family, just like you and me. And they lose their jobs overnight. And the most common reason for mill closure, which I've heard over and over again recently, was losing access to economically viable timber, high operating cost, and uncertainty in forestry policies. I've forgotten a lot of things from first year biology, but I still remember Dr. Michael Preston, my first year biology professor, showed us a quote from, I forgot who, but it goes, "Nothing in biology makes sense except in the light of evolution." The simple definition of evolution is the slow changes of a species over time. Genetic mutation and many other environmental factors cause each individual to show different traits. For instance, long hair versus short hair. And natural selection comes in and favors certain traits, so they have a high probability of surviving and reproducing under a given environment. For the longest time, BC Forestry has followed the classic European forestry model, which is cut it, site prep, create an ideal growing condition for seedlings, plant those seedlings, and come back and spray it and brush it and help them grow without competitions. And thin them at a certain age, and then voila! Those planted trees are now big enough so we can cut them down again. I think it's fair to say many other values were being considered while we were chasing the timber value, just to be fair. But the emphasis was on timber, volume, and growth and yield. FERPA, which governs forestry activities on Crown land in BC, used to load with language like without unduly reducing the supply of timber from British Columbia forest. To put it simply, if you want to come up with a measure to protect non-timber value, legally, you have to do it in a way without unduly reducing the supply of timber from British Columbia forest. But about 2 years ago, that language was completely removed from FERPA and Forest Planning and Practice Regulation. Don't get me wrong, I think politics plays a crucial role in BC forestry. But as a forestry community, we are currently under a selection pressure to maintain biodiversity. We're under a selection pressure to maintain post-harvest ecosystem service complexity. We're under a selection pressure to incorporate First Nation decisions in BC forest management in a meaningful way. We're under the selection pressure to truly make sure our kids and grandkids and their grandkids can still benefit from the forest sectors in the future, even though we are also under the selection pressure from stakeholders, our own families and bosses to make profits and keep the mill running. Perhaps those who can figure out a way to adapt will survive and continue their legacies. It's complicated stuff. I used to play a game called SimCity, and if you build an industrial area for forestry, it will only attract people with low education. It pissed me off because it really is not. It's one of the hardest things in the world to do, and we need talents. We need people with a variety of education backgrounds in forestry, and we need a strong leadership to get things done.